Greetings, class. Welcome to CSC560 Operating Systems, Week 5. Today, we're going to basically be jumping into file structures. So far, we've covered processes, we've covered memory, we've covered hardware devices. Today, we're going to talk about file structures. And file structures, really, no matter where you are, what particular device you're using, what operating system you're using, the key common thing with all of them is all of them are supported by file structure. So the operating system has to basically be able to control that, as well as every other thing as far as memory devices and processes. So let's go ahead and get started. Starting with file systems and storage management. The fundamentals of file systems. File systems organize data, okay, on the storage device and provides a logical view of how files are stored, named, accessed, and protected. So, key points. Purpose. Purpose of structure is for storing, organizing, and retrieving data. Okay. That is the purpose of a file structure. How do we organize it? Of the millions of bytes that we store, how do we make it efficient? Okay. And the key thing is when we make it efficient, we're talking about, as we're going to talk about later, excuse me, the file operations. What are we making efficient? The file operations, the create, the read, the write, the delete, the rename, the search. Those all are the things that we do with data. Okay, and that's why we're organizing. Components, okay, of a file system are the files. The directories are more common. What we use is folders. We talk about putting things in folders. And the benefits we get is data organization. We get better security, we get sharing, reliability. And we have different types of file systems. For example, NTFS and FAT32 are the older and newer file systems that are used by Windows. EXT4 is used by Linux, and APFS is used by Apple or Mac. Okay, so you'll think you're going to probably have assignment for that. Okay, so know the differences as far as what may be on the quiz. Okay, so after looking at the file system fundamentals, next thing we can talk about is file structures. Okay, file system structures define how files and directories are arranged and how relationships between them are represented. Okay. Key points. There's a hierarchical structure. Files are organized in a tree sharing or tree starting from the root of the directory, okay, to the lower level files. So if you look at this in this particular case, we start out with the name of the top file, and that file is broken down into sub files here, and then those sub files are broken into individual files. So that's basically from a hierarchy structure. The next one is directory versus file. Directories contains files and other subdirectories. So this is basically what would be happening if we had a directory structure also. We would have the directory and the files under it. That's basically what we're defining here as well. Okay. So a directory versus a file, I don't necessarily have to have a directory, but the directory gives me a quick way to search and find information easier. Okay, inodes, okay, stores file metadata, size, permissions, timestamps. Metadata is information about the file. And this is a term that you'll see quite often. Is your files contain the data of what you're actually storing. The metadata is information about the file that is storing information. So you'll see metadata quite often. Path names, absolute paths starting from the root versus relative paths based on the current location. Okay. Path is basically defined, for example, here. This might be file A, this might be directory A, It may, in fact, go to a directory B, which may go to a directory C, which goes to a file. Okay, from A to B to C to D to file. Okay, that is the path. Okay, that's the path. How do I get from where I am, get to the data that I need? Okay, okay, so absolute path, relative paths, navigation. Okay. Navigation, we have CD, IS, PW, make directory, okay, RM, MV, MRD, okay, examples. There is a homework assignment on this, okay, for you to do some research and looking up what these particular navigation schemes do. Okay. And again, like anything, if for some reason I don't give you a given definition for something, you are to do what? Okay. Yeah, I know. Everybody all together. Okay. Look it up. Okay. So, yeah, take that initiative of finding out. Okay. Everything that I've basically listed here, there may be some questions. Your first goal is to go out and look for it. Okay. Find it. Research it. Okay. So next thing we have storage allocation methods. How do we allocate storage for a file? We talked about allocating memory. Now we're talking about how do we allocate storage, which are basically are probably going to be on hard disk or on file structures external to your laptop itself. So it has a similar lookout as far as things we look for as we did when we talked about memory. Okay, this time we're talking about file storage. So we have contiguous allocation. File occupies consecutive blocks. Fast access, but prone to external fragmentation when we put things in continuous blocks. Then we have linked allocation. Each block points to the next. No external fragmentation. Slower access. So I have a block of data. I have it linked to my next block of data, which is linked to my next block of data. Okay. That linked allocation is a quick way I can get from each piece, okay, of the file that I want. Now, how is that different from contiguous? Contiguous says that, okay, I'm going to have a piece of storage, okay, for my file. Okay. And then I'm going to have a piece of storage for somebody else's file, and then another piece of storage for my file. Okay. Linked, I can get directly from the first piece of my file to the second piece of my file. Okay. If I don't have a direct link, then what I have is fragmentation, because I in essence, have to read through that next file that's adjacent to me before I can get to my next piece of data. So not as efficient, but can happen, okay, very easily. Can happen when multiple programs are storing information, and basically that information is being overlapped as to the location of where it's stored on the disk. Okay. So there we go to our linked allocation. Index allocation uses the index block to store pointers of all the file blocks. That's similar to linked, okay, but we're basically taking that information and have a particular specific location as to where each block is located, so we can get to those blocks directly. Extent-based allocation allocates continuous blocks in extents. Uses a modern file system, for example, NTFS, okay, to keep track of it. Okay. Extent-based, again, is similar to the other ones as far as length. How do I, link the pieces of my data that's across across a disk? Okay. Okay. How do I do that? And that's extended base allocation. Windows uses NTFS. Considerations, efficient fragmentation, speed, and storage. Now you notice it says efficient fragmentation. Fragmentation is going to happen. Unless the only way that fragmentation doesn't happen is when you're the only one storing. Okay. If you're the only one storing and there's nobody else storing to that particular location or disk where you're storing information, then you don't have to worry about fragmentation. But that is not the case. Never happens. Okay. What you're looking at is hundreds of programs writing different files to different places to the same place. And, we're trying to keep track of these hundreds or thousands of programs that are storing information. Okay, so next one is directories and metadata. Remember, metadata is data about the file itself rather than the contents of the file. So key learning points, metadata, data about file name, size, type, owner, directory entries, map file names to metadata. So that's basically a table that says here's my file name, where can I get information about, the data or the characteristics of that file. That's in a directory of itself, a metadata file. Timestamps, when did I create the file? When was the last time I modified it? What are the access times? Basically tracking the history of the file. Permissions, control who can read, who can write, who can execute files. That's the permissions. That's other metadata about the file. Importance enables security, accounting, backup, efficiency. What is the metadata as far as what kind of security should I have on this file? Okay, so so far file system fundamentals, file structures, storage allocation methods, directories and metadata, and then finally file system performance and reliability. Performance factors, the speed of your disk, your caching, allocation strategy, and fragmentation. Okay. Each one of those we've talked about previously. Caching, temporarily stores frequently accessed data in memory, by whether it's a page cache, a buffer cache. It's basically taking that information that I might need at a given time and basically bring it into memory so it's already there, so I don't have to go out to the disk and worry about fragmentation or worry about link bits. Okay, because I pull that information into memory and it is available. Journaling, record changes before writing to disk. Record changes before writing to disk to protect against corruption. So we might journal. So we know at each point what happened to the data. Data gets lost at times, okay, or can get lost. I mean, you can have bad disk, you can have corrupt disk. So you need to be able to keep track of that information about the file itself and what states they were in at all times. Okay, so redundancy and backups, RAID, that's one of those terms I want you to look up. Snapshots and regular backups, improve reliability, reliability goal, maintain data integrity and availability. Again, all this is basically keyed off of, I have to save information. If I don't save information, and then I'm probably in a bad shape. So if I have to save it, what are the things that I have to think about? What are the things the operating system has to think about in order to come back to the key file operations? I create a file, I read a file, I write a file, I delete a file, I rename a file, and I search a file. For those functions that I have to do with a file, I have to maintain. That coupled with the metadata that describes the files or file structure itself, that's what I'm controlling with the operating system. Okay, takeaways, file systems provide structure and method that allows operating systems to store, organize, and protect data efficiently. Our goal is to learn how operating system design and manage systems, storage resources, and organize data, protect information, and deliver it to you fast. Okay. So that's basically looking at our file systems. Again, look at the high levels, study this particular video, And, we will have a brief quiz on the major portions. You know, they be at least you should be able to say, what is a file? Okay. I'll go a little deeper than that on the quiz, but as far as what should I be looking at? Okay, so that's it for today. Next week is the next or the last week for basically a lecture. When we get into week 7, we'll be talking about the project, more of how we're putting together what we've done in the labs. So this week is going to basically roll into that. Next week will be advanced, basically looking at some advanced concepts I want to make you aware of, okay, that we won't be going into deep, but we'll be more looking at that as what's you can expect in the future, what can you expect now as you get out into the business world. Okay, so that's it. File systems and data storage management. We will see you on Tuesday. Have a good one.